All right, so we're going to start with finding the area of a triangle. I do think that, like I said, this topic is pretty straightforward. Having done law of cosines, law of sines, and now the area of a triangle. Now, I kind of want to take a moment, just kind of think through like how the area formula comes about, and I mean, because you're going to see in a second, and if you have the packet, you have it in front of you also. But before we kind of like just jump right into it, I really want to like just dive in for a second to see like, okay, well, how are they getting this this formula? So I know that the area of a triangle, so normally that's equal to 1/2 base times height. That should be pretty obvious. So looking at this specific triangle, FGH, I know that the base is 10, which works out for me. So 1/2 base is 10. But the problem is I don't know what the height is. So I don't know what the height is. That's the problem. Luckily for us, they do give us the angle measurement of one of the angles as well as this other side, which seems to not be helpful in the beginning. But if we take a look, if since my height is a vertical line straight down to the base, I actually have this other triangle that I have that is a 90-degree triangle. Or I'm sorry, that's a right triangle. So I can actually use my Pythagorean theorem. I'm sorry, not Pythagorean theorem. I can use my trig ratios to find what the height is, specifically using this angle of 40 and 8 meters here. This is effectively now my hypotenuse for this triangle. I can set up the equation using sine because sine is opposite, and this side is the opposite side of my angle. So I can use sine of 40 degrees is equal to, now in this case, I don't know what h is, so I'm just going to leave it as h over my hypotenuse, which is 8. So this may look familiar because this is exactly, well, this is basically what we did in Algebra 2, where you did this in order to find the value um, of how high or how low you are on the Ferris wheel. But now I do have a value for what h is going to be. So in this case, that is going to be or I'm sorry, the area now that I do have a value for my height is 1/2 base, which is 10, times the height, which I have just solved for, is 8 sine of 40 degrees. And we can generalize this because you can see that really what you can do this for any triangle where you have two sides of the triangle and the angle in between, and you're going to be able to solve for that. So that's really where this formula is coming from. You can see that AB sine of C, where C is an angle measured in degrees, and A and B are adjacent sides to an angle C. And again, we'll finish this off by actually calculating this out. But you can see again, you have this angle 40 and 8 and 10 are the two sides that create this angle or are the adjacent sides to this angle. And so let's just go ahead and put this in the calculator. Now, obviously, it doesn't really matter if you want to, first do 1/2 times 10 or whatever. I'm just going to go ahead and just put it all in without having um, multiplied anything out. So I have sine of, what is it, 40 degrees. Oops. And I have this value of 25 point. Let's do the, I think they don't ask us to, yeah. It's 25.7. I'm in degree mode, degree mode. I don't, 25.7. I don't know why I forgot it. 25.7 meters squared because we are talking about area, so it's going to be squared. Now, just as a side note about the units and stuff like that, notice that here I have, essentially I have 10 meters multiplied by 8 meters, and everything else is a scalar value, meaning it's just a number. There's no units associated or a direction, right? So in this case, what I do get is meters times meters. That's why I have meters squared. But again, this is how I got my equation. We'll just do a few examples. and that'll basically be it. All right. So again, we have area of a we want to find the area of a triangle. Again, you want to find two sides and the angle in between. In this case, I don't have that, but they do give us two other measurements of this triangle. So I'm going to do 180 minus 62 minus 75. So I do get 43 for my missing angle here. Area, pretty straightforward. I have 1/2. Doesn't really matter which side you want to do first. 11, 10, sine of 43. It doesn't really matter as long as you're multiplying the sides of the angle adjacent to the angle, you should be fine. So again, I should have 0.5 times 11 times 10 sine of 43. You get 37.51 units squared. 37.51. Yep, looks good. All right, let's keep it moving. Let's change the color for a second here. Now, again, this is side, side, and this is the angle in between, so we're good to go here. You don't, and notice that it doesn't have to be like, they don't have to give me like this side and this angle measurement, right? Even though like I know that generally we think about, base times height, whatever. But again, you could rotate this, right? So that this now becomes your height. I'm sorry, your base. So you have a base value. This you can find um, the height in this way, where you can technically draw a vertical line this way to get your height, whatever. But that's not a big deal. As long as you have your angle and it's the two adjacent sides, you're good to go. So again, the area of this triangle is equal to 1/2 21 times 32 sine of the angle in between 87 degrees. So that's equal to 0.5 times 21 times 21 times 32 sine of 87. Okay, so 335.54 units squared. All right, we'll just do a few more examples here just so you make sure that you get some similar things that I get. Again, you want side, side, and the angle in between. In this case, again, I am missing the angle in between. So I think this is the hardest, quote unquote, hardest part. We really be careful here. 180 first minus 53 minus 68. Whoops. I get 59 degrees as the missing angle measurement. But after I do that, I have all the information that I need. So again, the area is equal to 1/2 17 times 12 sine of the angle in between, 59. 17, 12, 9. So 0.5 times 17 times 12 times sine of 59. 0.5, 17, 12 sine of 9. Yep. Okay, 87.43 units squared. And this is my area. All right, so let's take a look at a few word problems and then we'll wrap this video up. I think this is quite a quick one. Baseball infield is determined by a square with sides 90 feet long. In the diagram, home plate is H, first base is F. Suppose the first baseman ran in a straight line from F to catch a pop-up ball at B 120 feet from the home plate. If the measurement of FHB, which I label force, is 10, how far did the first baseman run? Question mark. Which tells me I want to go from F to B. This is where the first baseman ran. I'm looking for this value here. So actually, this is not even a area of a triangle. This is just simply looking for a side length. And I did forget we're covering a little bit of word problems here. So here I do want to make sure that either I'm using the law of sine or I'm using the law of cosines. And again, just as a reminder, in order to use the law of sines, you really have to look for if there's like a pair, ratio angle pair that you could use. In this case, I do not, right? I have the quote unquote pair of 10 and x, but I'm looking for x, right? So that means I need a different pair that I can actually set up some kind of ratio for. In this case, I don't have that. And so therefore, I am going to use the law of cosines. I'm solving for the side x, x squared. That's going to equal to the other two sides individually squared minus 2 times 90 times 120 cosine of the angle in between them. And notice again, I'm going to move this down for a second, just in case for just in case of those that don't remember the equation and is kind of wondering like, where the heck are you getting this number from? Remember that the general formula is c squared is equal to a squared plus b squared minus 2ab cosine of the angle c. So again, don't get too caught up on the letters here, but really whatever is on the outside should match up. Your side C and your angle C, right? These are the two that should match up on the outside, but then on the inside is just it's just the other sides, A and B, whatever the other two sides are going to be, right? So in this case, my 10 and my X are the quote unquote ones that match up, and I'm solving for one of them. And then the inside is just the other two sides. The order doesn't really matter. You can call this one A, you can call this one A. It doesn't really matter. But the only thing here I need to do to solve here is just going to take the square root on both sides. Now, do be careful. I saw a few papers where people would take the square root of each individual one, each term. Please don't do that. If you're taking the square root of x squared, you're going to take the square root of the whole thing, right? So all I'm going to do here is I'm going to type in this whole thing. I'm not going to even bother separating it, like saying one term at a time. I'm just gonna put it all in, let the calculator do the work for me. Right. So therefore, I have this value of 30 point. Does it say what round? Okay, no. So 30.05. Let's say 35.05 feet. Ugh. Okay. Another one, a student geometry guy is assigned a task of measuring distance between two trees separated by a swamp. The student determined the tree formed by A, dry point C, and tree B is 27. Notice that these three right here, the angle formed by this is the same thing as saying angle ACB is, or measurement of angle ACB is equal to 27 degrees. ACB is this guy right here, right? That is 27 degrees. Okay, they also know that angle ABC, this is 85. Okay, if AC is 150 feet, how far apart are the trees? And they tell me the two trees are tree A and tree B. So I'm looking for this guy. Now, this time it is very good that we do have a angle and side pair. 85 and 150 are across from each other. I can solve for that, set up a ratio in that way. Now, some small thing that we talked about, so this is going to be law of sines. Now, something that we kind of talked about is it doesn't really matter if you put your angle at the top or your angle at the bottom. I personally like to put my variable on the top. So in this case, my side should be on the top. So x over sine of 27. And that should equal to my side, 150, over sine of 85. Now, the reason I like doing this is because now all I got to do is multiply by sine of 27 on both sides. And I don't need to go through the process of cross multiplying, right? Because if I cross multiply, then I got to divide again later. In this case, that cancels. I'm just going to have x is equal to directly 150 multiplied by sine of 27 divided by sine of 85. Right? So there's like one, kind of like one less step that I have to do, sort of. I just got to multiply and that's it. So 150 sine of 27 divided by sine of 85. I get 68.36. And this is in feet. Cool. And the last group problem that we'll go over today, two lookout towers, L and M, are 50 kilometers apart. The ranger in tower L sees a fire point C such that M equals CLM is 40 degrees. Ranger in tower, I don't know why tumor, M sees the same fire at measures. So let's just draw it out first. So I have some triangle, and again, it doesn't really matter how you draw it. L and M are 50 kilometers away, and L sees point C where CLM is 40 and CML is 65. So we're kind of pulling our geometry knowledge here. Okay, how far away is the fire from L? So we're looking for this guy right here. Now, be careful because off the bat, it might be like, oh, okay, I don't have a pair. It looks like it's going to be law of cosines. But again, we do actually have this hidden value because I have 2 out of the 3. This is 105, meaning this must be 75 degrees. So I actually have a relationship, a ratio of 50 over sine of 75. And that's equal to x over sine of 65, right? So I can actually solve for this by multiplying sine of 65 on both sides. So I'm going to put into the calculator 50 sine of 65. This whole thing is divided by sine of 75 degrees. Okay, so 50 sine of 65, divided by sine of 75. I'm going to get 46.91 kilometers is equal to x. Okay, and that kind of wraps up our video for area of triangle as well as some word problems. Again, I do think this is fairly straightforward. I do hope that this made sense. If you have any questions, please feel free to ask. Thank you.